Alright, so in this video we're going to basic tank settings. Notice that we have our tank level going automatically up and down based on this oil operation here, which we did in a different video. So we'll bring up the control panel for our tank. We have a trend showing our last 24 hours. Because we're updating this rapidly, we have some very close trend lines. We have our current tank level. We have our rate change, which right now is not active because it's updating rapidly. We didn't turn it on because the values would be just rather odd. But it goes based on the update cycle of the equipment in the field and shows us an estimated rate of change, whether it be up or down, based on the level we're watching. So in the case of a tank, it'll be a rate of change of how many feet is changing per minute. We have our control inactive and active. Inactive will set the level to a static and will stop updating the level. That's good for doing tank calibrations. Notice on the trend here we have it set completely inactive. It's all 0 right now. Alright, so set it active again, and I'll do that again one more time just so you can kind of see tanks going up in the background. So because we have the pumps going, and we'll set it active again. Okay, so if we click on our trend, we can get a larger view. We've got the window shrunk down right now, so get that. You can drag it around and get a specific time and see the level at which it was running at that exact time. You can set your time spent you want to view: 1 hour, 6 hours, 12 hours, 1 day, 1 week, or 2 weeks. Now notice that we have another video showing how to do the trends in a more advanced graph that is supplied with the Measurement and Automation Explorer. Alright, so back to the main control panel here. All of our settings for a tank are in the setting and options area here. You click there. It brings up things such as alarm levels for high and low, rate of change alarms, so maximum rate of change, and then a stale being level not changing. Our scaling and display, so this is our input that we're getting from the device, and this is our scaled output. Our trend lines, and that we have a minimum maximum display, so we can set this for a minimum of say 2. It'll adjust our displays automatically, including the graph on the left side of the tank. Right, so limit means that we won't display any value, but that'll limit the value to no more than 20 or no less than 2. So right now if we have this set for 10 and 2, notice that even though we may be actually getting higher than that, we're going to hit 10, and the tank's going to keep on going because we limited the value artificially to 10. Alright, so we'll go ahead and make that a little bit higher. Alright, so there we go. I'll set this back to where we were at 20. Alright, so let's set our high level. So we want the tank to give us an alert when the tank gets to a certain point. Depending on your overflow level of your tank and things like that, it depends on where you'll set this. So say you have a tank that's, in this example, we have a 20-foot tank, but our overflow is actually 18, and we're pumping up to about 15. Probably a good safe place might be probably about 17. Because it depends on how fast your tank's filling, things like that. So we'll set this for 16, and we'll set our low level. We'll set that for 2.5. So what's going to happen is every time this tank goes below 2.5, it'll generate an alarm. Every time it goes above 16, it will generate an alarm. So right now it's on our way up, and notice we didn't hit our high level, which is good. But it's on its way down, and we have set for 2.5, and now we have gone below 2.5. We're going to generate a red alarm. Alright, and we have our delay set for 5 seconds. That's the minimum. We don't want any. We want to make sure this thing's actually having a real alarm, so we can give it a little bit of delay before it considers it a true alarm. It'll still show us a status indicator saying it's high or low. Alright, so let's go ahead and set the low a little bit higher. So we'll set it for 5. Alright. So it's on its way down now. And it's going to get below 5. Alright, so our alarm's having an issue. And we just went over 5 seconds and it generated a new alarm. Alright, and again, you can actually go into your trend and you can see your high and low level alarm points. Of course, we have a lot of data on this graph, so this is not the normal view. So we have our level low of 2.5. Alright. Now stale, what that means is how many hours, if the level does not change, if we have no change in the level for a set amount of hours, it'll generate an alarm. That could be an indication of that the transducer is not working, or some other odd issue that's happening out in the field. It can happen sometimes, like, for example, if a sensor freezes in cold temperatures, a lot of times the level will stay flat. So you can get an alarm on that. Rate change max alarm means that any change over this amount within the time span, which is a minute on this one, it will generate alarms. So if we were to set this for 2.0, if we had a rate of change of 2 feet per minute or negative 2 feet per minute, it would generate an alarm if this is checked. Now, probably one of the most important things in the tank is the scaling. So for that, your best bet is to set it inactive. Okay, and you're going to go into edit mode. You're going to find your tank. So right now we have this temp analog, and it shows you right here inside of the display, scaling, set site to inactive, enter edit mode, locate the folder, right click on con level, and click edit data member configuration. So again, we're inside of our edit mode, we have our object explorer, and this folder is temp analog. Typically the folder name is right here on the title, not every case. So temp analog, we find our con level, we right click, and let me actually bring that down a little bit so we can see it in the video. And we go to edit data member configuration. And so we'll close that window just to get out of the way. Alright, so we have this scaled. So right here we have our 0 to 100. So raw units. This is the raw reading from the device in the field. So right now it's from 0 to 100. There's our input right now at 100. So let's say we had a 16-bit device. That means that we'd have 0 to 65535. Now this is, of course, these numbers are not truly accurate. You have to get a minimum and a maximum using a analog calibration tool on the module, and then you can actually adjust it based on the devices put out in the field. So using approximate numbers on a 4 to 20 module, that's actually, well, a 0 to 20 with a 4 to 20 sensor, 13107 is about 4 milliamps. And so anytime we have a reading of 13107, we get an output of 0. Anytime we get to 65535, we'd have 15. So a value in between here, but between proportionally between the engineering units as well. So we'll set this back to where it was. We'll update, we'll quit, and we'll go back. So let's actually go back to that, and we will make another value so it kind of shows you the level change here. Edit data member configuration. We close that window. And let's say that anytime we go below between 0 and 100, we're going to change that to 0 to 50. So if we're at 100 raw units, it would be 50 engineering units. Let's go ahead and go back into run mode here, and we'll set this to active. So notice that our tank level is extremely high because we have it scaling from 0 to 50 now instead of 0 to 15. So it's dropping very, very rapidly as well. So the pump's going to turn back on, and it's going to climb very rapidly. So now we're getting a high level, we're getting a low level, we're getting all kinds of things going because of how fast we're updating this. And again, this is a fake value. It's not what you would expect in the field. That is it for the tank settings.